This is a common data question which is given for 4 marks, which consists of 2 sub-questions, each carrying 2 marks. It came in 2006 for EC Gate. The question is, a regulated power supply shown in figure below has an unregulated input of 15 volts and generates a regulated output Vout. Use the component value shown in the figure. The regulator circuit is shown here. Now, the first question, the power dissipation across the transistor Q1 shown in the figure is. So, in order to find that, first we need to find what is Vout here. We know if this is Vout, the voltage at this node should be equal to the voltage at this node, because the feedback loop with the op-amp will make sure the voltages at both the inputs will be equal. Hence, the voltage across the 24 kilo ohms will be equal to Vout times 24 kilo ohms divided by 24 kilo ohms plus 12 kilo ohms. This will be equal to Vout times 2/3. Now, this voltage that is at or across the 24 kilo ohms will be equal to 6 volts. As we just discussed, the voltages at both the inputs of the op-amp should be equal. In that case, Vout will be equal to 18/2, because I am just equating the 6 volts to this equation. Hence, I got this. This will be equal to 9 volts. So, the output voltage will be 9 volts. If that is the case, now to find the power dissipation across the transistor Q1, we need to find PQ1. This will be equal to VCE times IC. Now, VCE will be equal to the input voltage minus the output voltage, which will be 15 minus 9 volts times IC. This is 6 volts times IC. Now, we need to find what is IC. Now, we can say IC is approximately equal to IE, because we are not given any values related to beta or anything. Hence, we will take IC and IE are both equal. Now, in order to find IE, we know the current that will flow through this 10 ohms resistor. This current will be equal to 9 volts divided by 10 ohms, which will be 0.9 amperes. Now, if you want to look at the current that flows through this one, because we know the current that is taken as the input by the op-amp will be 0. Hence, as we know, the voltage here also is 9 volts. The current flowing through this will be equal to 9 volts divided by 36 kilo ohms, which will be 1/4 milliamperes. So, hence, IE will be equal to 1/4 milliamperes is 0.25 milliamperes plus the current through the 10 ohm resistor, which is 0.9 amperes, which is in fact 0.25 milliamperes plus 900 milliamperes. So, compared to 900 milliamperes, we can neglect this 0.25 milliamperes. This is the whole point where we always talk about the voltage divider network to be of very large resistance values, so that it does not consume current driven by the BJT or supplied by the BJT. Now, taking this approximately equal to 900 milliamperes, let us substitute that here, as we just assumed IC is equal to IE. Now, PQ1 will be equal to 6 volts times 900 milliamperes, which will be 5.4 watts. Hence, the correct answer for the first question is option C, which says 5.4 watts. Now, let's move on to the second question. The second question is, if the unregulated voltage increases by 20%. So, unregulated voltage as of now is 15 volts. If it increases by 20%, this will result into 18 volts, which is 15 times 1.2, which is 18 volts. The question is the power dissipation across the transistor Q1. what happens to that. So let's see that for the second question, PQ1 will be equal to, now we have to see for the highest voltage, which is 18 volts. This will be equal to 18 volts minus, as it is a regulated power supply, the output voltage will still be at 9 volts because the Zener voltage hasn't changed. It is still going to be at 9 volts. So we'll take minus 9. This will be the voltage across the BJT, which is VCE times IC, which in fact wouldn't change because the voltage at the output is still 9 volts. It hasn't changed. So the current will be still same. Hence, we can multiply this. This becomes 9 volts times the output current is 0.9 amperes or 900 milliamperes. So let's just put 0.9 amperes. This will be the new P-Q1, let's say. But if you look at the options, they're asking in terms of increases by 20%, increases by 50%, remains unchanged, or decreases by 20%. We can see from the initial case, obviously it has increased. By how much? If you observe here, it has increased by 50%. So how do I state that? So P-Q1 minus PQ1 divided by PQ1, if you see, we'll know how much it has increased by. 8.1 minus 5.4 divided by 5.4, which is 2.7 by 5.4. This will be equal to 0.5. This will be equal to 0.5. In terms of percentage, it is 50%. We can see here there is a 50% increase in the power dissipation across the transistor Q1. If you like the video, please give a thumbs up. If you haven't subscribed yet, please do subscribe. And thank you for watching.